In this video, we're going to look at the relationship between max and mins and the derivative. So anytime we have a relative maximum point, it's the point where the graph changes from increasing to decreasing. So my curve is going up and then it goes down, and at the point where it changes is the max. And for this max, again, we know that the derivative at that max, so if I call this a, is equal to 0. But if my function is increasing, we said then the derivative would be positive. And then my function changes to decreasing, where the derivative then becomes negative. So here the derivative is greater than 0. Over here, the derivative would be less than 0. So at a max, we know that the derivative is going to equal 0 or be undefined, and that the derivative will change from positive to negative. And anytime that is true, we have a relative maximum, also known as a local maximum. So they might say local max, that's the same thing as a relative max. For a minimum, it's the opposite. So for a minimum, we know that the graph changes from decreasing to increasing, which means if my graph is decreasing, the derivative of this function is going to be less than 0. And then after that point, it changes to increasing, so my derivative is greater than 0. And again, at the max or min, which we call a turning point, the derivative is always equal to 0 or undefined. And we will mostly be doing the case where it's equal to 0. So anytime the derivative changes from negative to positive, we have a relative minimum point. So, oh, and one other thing, this could also be called, sorry, a local min. Now, on a graph, sometimes we have a point that is the highest point of the entire graph, and that is called the absolute maximum. So the maximum value, or the absolute maximum, is the largest y value that a function reaches. Another name for it is a global maximum. And that is the highest y value, or the largest relative max. So all of these points where my graph changes from increasing to decreasing is the max. So here is a local max or relative max. Here is a local relative max, and here is a local relative max. And then if we have a function, if one of these maxes is the highest y value anywhere in the function, that is called an absolute or a global max. So this y value here at 4 would be the absolute max. And then the minimum value, or the absolute minimum, is the smallest y value that a function reaches. Okay, now in this graph, my function has an arrow where it keeps going, and so there is no absolute min because my function keeps going down and down and down. But if I had a function like this, where it either has endpoints on both sides, or it would only be continuing up in the positive y direction, this would have an absolute min here. So that would be the lowest y value. So if we have an absolute min, we also call it a local min, because it is a minimum in that region. But the absolute min is the lowest y value on my function. Right? And then again, the absolute max is the highest y value in the function. Now there's one other feature where the derivative can equal 0, and it's called a plateau point. So a plateau point is where the derivative equals 0, but there is no max or min. Okay, so the derivative will not change sign. So on this graph right here, C is called a plateau point. And so we can see the function is increasing before that point, and it continues to increase. And so the derivative is greater than 0 until we get to the plateau point, and then it's greater than 0 after, but at that point C, the derivative is equal to 0 because I have a horizontal tangent line, and the slope of that horizontal line is 0. You can have the same case if my function is decreasing the whole time. The derivative is less than 0, At C, again, the derivative is equal to 0, and then after C, it stays decreasing. So my derivative stays less than 0. And so this is also called a plateau point. Now, one thing, if we go back to this graph, is if we have endpoints on our graph, okay, so this would be an endpoint here. Endpoints are always max or mins. So this endpoint here is a local min because it's the lowest point in this value. There's an endpoint here, and this is a local min too. And then this endpoint here is a local max. Okay, so endpoints are always local mins or max. They could be global if they're the highest or the lowest. And so how it works is if I have an endpoint that's on the left of my curve, so this endpoint is on the left, if my function is increasing after, it will be a minimum. So that means the derivative will be positive before that point. If I have a right endpoint, it has to be lowest the point, which means the function will be decreasing before that point, which means the derivative will be negative before that point. Okay, and then maxes are the opposite. For it to be a max, if I have a left endpoint, my function would be decreasing after, so then derivative would be negative after. And if I have a local max on the right, like here, before it, my function is increasing, so the derivative is positive before it. So this is a summary of all those things. Anytime my function is increasing, the slope is positive. Remember, slope is the derivative, so the derivative is positive, or f prime of x is greater than 0. If my function is decreasing, my slope is negative, and so f prime of x is negative, or we can write as f prime of x is less than 0. At a max, that's not an endpoint, my slope would have to be 0 or undefined, and it has to change from positive to negative. So that's the same true for the derivative. Just remember, derivative is the slope. So the derivative would have to be 0 or undefined, and my derivative changes from positive to negative. The min, again, not endpoints, is the opposite. So again, it's still 0 undefined, but the slope changes from negative to positive. So the derivative changes from negative to positive, and the derivative is equal to 0. A plateau point and the slope is 0, but it does not change sign. So the slope is equal to 0, the derivative is equal to 0, but f prime of x is either negative before and after, or it's positive before and after. And then these are the rules I just talked about with the endpoints. So if a left endpoint is a max, that means my function is decreasing after it. And so the derivative is negative and the slope is negative. Okay, and usually I draw these to remember it because it's hard to memorize, but if you draw a picture, it kind of helps you. So if I have a right endpoint that's a max, so here's a right endpoint that's a max, I can see my function is increasing, which means the slope is positive right before that endpoint. So the derivative will be positive. Okay. If I have a min on the left here, right after it, my function is increasing. So that means my slope will be positive right after it. And f prime of x will be positive right after the endpoint. And if I have a right endpoint that's a min, then my function is decreasing right before it. So the slope is negative and the derivative will be negative right, that should say before the endpoint. And so this is a summary of kind of all of those rules. So let's look at a graph and describe these intervals. So we want, where is f of x increasing? Okay, so again, we're going to use interval notation. We're going to find where my graph is increasing. So it looks like it starts here, and then my function is going up until I get to 2. So I'm going to write this as negative 1.5. Okay, or negative 3/2 to 2 is one place my function is increasing. And then if I look again at 4, it is going up until we go to positive infinity. So the other place is 4 to infinity. Okay, where is my function decreasing? Okay, so if I start on the left, it starts decreasing until I get to negative 2. So that's negative infinity to negative 2. Yeah. And then it's also decreasing from 2 until I get to 4, and then it starts increasing. So from 2 to 4. So then it says, where is my derivative f prime of x positive, where is it negative? So a derivative is positive anytime it's increasing. So it's the same intervals as where f of x is increasing. So it is positive from negative 1.5 to 2 and 4 to infinity. Because if my function's increasing, the slope is positive. And it's negative wherever my function is decreasing, which is negative infinity to negative 2 and 2 to 4. Then it says, where is the derivative 0? So the derivative is 0 anytime there's a horizontal tangent, and that's anytime we have a max or a min. So here, here, and here. Anytime my function changes from increasing to decreasing, my derivative is going to equal 0. So I give the x values because it says where. So I'm going to say x equals negative 1.5, 2, and 4. And you can just put a comma between those. Okay, so these are the three values where the derivative is equal to 0. And then it says, what are the critical points? Okay, because it says point, I want to give the points. So my critical points are at the max and min. So we have this point here, which is negative 1.54. Then my next critical point would be here at 2, 0. And then my third critical point would be at this local min, which is at 4, negative 1. And just if they asked about absolute max or absolute mins, for this, there would be an absolute min at, this is the lowest y value. Oops, sorry, this should be negative 4. This is the lowest y value at negative 4. So the absolute min would be negative 1.5, negative 4. And then there is no absolute max because my function keeps going up. And so the y value keeps increasing. So that's just a summary of how the derivative is related to the increasing, decreasing, and the turning point.